Good morning. I am Dr. Subashini, Professor in IT Department in Beltech Multitech, Dr. Dr. Shakuntala, Engineering College. Today's topic is going to be about searching in data structures. Searching. So first we have to know the definition for searching. It is a process of finding an element in a data structure. So how to find an element in a data structure? It can be done using algorithms like linear search and binary search. So let us see in detail about every search algorithms. Linear search. So as the name says, we are going to search the list linearly or sequentially. So let us discuss about the steps. First step, what you have to do is that you have to get the total number of elements. So how many elements we are going to store in the array. So that is the very first thing which you are going to get as an input. And for that, those elements we have to allocate memory, and we are going to get the elements one by one. That will be the next one. And then you have to give the elements which you want to search in the list. So our objective is to find out the element. We are going to find out an element whether it is going to be in the list or not. So that is the search element. And then for each element in the array, we have to check whether the element is same. So line by line, right from the beginning of the array, you have to see whether the search element has matched with the element which is already in the list. So we keep on moving till the match comes. Okay, so once we get the match element, at that time we have to stop and we have to display that the element has been found. If suppose no elements has been matched. If suppose you come to the end of the array and you didn't find the match element, in that case you have to display that the element is not found. So I just explained this with an example. Consider these are the n number of elements in the array. So totally I have inserted 7 elements in the array. So the very first element starts with the array index 0, next 1, 2 till 6. So totally we are having 7 elements. But since the array always starts with 0, so I started with array of 0, okay? The element which I want to search is 4. I just want to check whether 4 is present in the list or not. First, in linear search, what should I have to do is that I have to compare the search element 4 with the first element in the array. So I have to check whether these elements matches. Do 4 matches with 30? No. So in that case, the first element didn't match. Next, what you have to do means you have to move on to the second element and you have to find out whether 65 matches with 4. Now the element didn't match. So you have to move on to the next element. So you have to check whether 40 has matched with 4. No, it didn't match. I move on to the next element, which is 4. Yes, the fourth element in the array has matched with the search element 4. So now you have to display that the search element has been found in position 4. So this is how you do the linear search. So let us see the program for linear search. As usual, you have to give the header files, okay, and then you have to declare the variables. The variables, the array name, I used array. So and then the element to be searched, we are going to store it in a variable which is known as search. In the previous example, the value which we were searching was number 4. So we store 4 in this search variable. And now what you have to do, we have to give the number of elements, total number of elements. How many elements you are going to store it in the array. So that you have to store it in n. Next, after that, what you have to do is that you have to get the values, you have to enter the values into the array. For that, we make use of this for loop. Using this for loop, you try to store the elements in the array. Using scanf, you just store one by one into the array. And then you have to store the elements to be searched in the search variable. So that is the next step which you have to write. And next one, using this for loop only, you are trying to find out whether the search element is present in the list or not. Okay. So first what you have to do is that you start with the index 0. So array of 0, you try to find out if array of 0 is equal to search. For example, the previous example I showed, the search element is going to be 4. So I just find out whether array of 0 matches with the search element. If suppose if it has matched, you have to print that the percentage which means that search element is present at the location. So C plus 1, why? Because the array is going to be start with index 0. But when you look into the array, we say that 4 is present in location 4. So it will be better if you put C plus 1. Since if you have started the array with 1, you can straight away print the location as C. Since the array index is started with 0, we have put C plus 1. If suppose it displays the location where the search element has been matched. If suppose the search element is not found in the list and if C has become equal to N, in that case what you do? You have to print that the search element is not found. So this is how you perform the search operation using linear search. So this is how you get the output. So you have to enter the total number of elements in the array. In our example, we have taken 7 elements, and then you have to enter the elements using scanner. You have to get the input from the user. So I have given 7 values, and the search element is going to be 4. And once you run the code, the search in position 4 it would have been matched. So it displays that 4 is present at location 4. So this is how we perform linear search. So for each and every algorithm, it has its own pros and cons. The best case, you have best case, we have to analyze the best case and worst case of linear search. For example, if you are trying to find out an element 4, and if this 4 is going to be present in the beginning of the array, which means that either in the first position or the second position, if it is going to be present, then linear search holds good. Why? Because in the second iteration itself, the element is going to be matched and it is going to display that the search element has been found. For example, your array is quite big and you are going to have 100 elements in that, and the element to be searched is present in 99th location. So we have to consider all possible positions, right? If suppose the search element is going to be present in the location 99, so what you have to do? You can find the match only when you move to the 99th position, 99th location. In that case, the linear search will not hold good. So this is a drawback which we have in case of linear search. To overcome this drawback, only we go for binary search, which is the next searching algorithm. Binary search, when we go for binary search, what you have to do is that you have to create an array in a sorted manner. So the very first thing which you have to do in binary search is entering the element into the array in a sorted manner. And then it is used, what you have to do is that you have to find out the middle value, and then from the middle value, you have to find out whether the search element is going to be lesser or it is greater. If it is lesser, you have to move to the left sublist, or if it is greater, you have to move to the right sublist. So this is how you perform binary search. Here what are we trying to do is that we are going to follow divide and conquer strategy. Okay. So I'll just explain you the algorithm. So first you have to, as usual, you have to read the search element from the user, and then you have to find the middle element. So for that we make use of the formula low plus high divided by 2, or first plus last divided by 2. So with that we try to find the middle element, and then what you have to do is that once we find the middle element, we try to compare the middle element with the element to be searched. If it matches, you can display that the element has been found. If not, what you have to do is that you have to identify whether the element to be searched is lesser than the middle element. If so, what you have to do is that you have to move to the left portion of the list, which means left side of the sublist. Middle element means the left side you have to move. And if suppose if the element to be searched is greater than the middle value, means you have to move to the right side of the sublist. Middle elements, right side portion you have to move. So right side will be you have to keep on doing until we find our until we find out the search element. So this is how we perform binary search. And these are the steps which I explained in detail. So that is what. If suppose the element to be searched is not present in the list, in class what you have to do is that you have to display that the element is not found in the list. I just explain you with an example. So we have taken 9 elements in the list. So out of this 9 element, I want to find out the search element 12, whether it is present in the list or not. I just want to find out. So in that case, as you search. So with this, once you have iteratively done this, you have to find, if suppose if the element didn't match, you have to display that the search element is not found. So I think in tomorrow's session, we can discuss about a program of binary search.